Hello and welcome to Astronomy Answered Simply. Today's question: with how fast technology is advancing, will interstellar travel soon be feasible? Okay, so the first thing I want to know is, what do you mean by soon? How soon is soon? So, is it going to happen tomorrow? No. Is it going to happen in the next 20 years? No. Is it going to happen in the next 100 years? Still going to say no. Now let's start talking about thinking about interstellar travel and the necessities. Maybe in the next 500 years we'll be able to start interstellar travel. Maybe. 1,000 years, more like it. But I mean, in order to get to the nearest star, we need to have supplies to feed and house and oxygenate the crew from here to the next star. And the reality is, we don't have any technology that can move at even, a single percentage of the speed of light. So there's a problem there. Voyager would take 70, which is currently the fastest man-made object in space, actually the second fastest, because I think the Juno probe is faster than Voyager. But Voyager 1, which I'm more familiar with the statistics on it, it's moving at 35,000 kilometers an hour out of the solar system, and slowing a little bit as it goes because of the gravity pull of the sun, but it still has escape velocity and it will still eventually leave the solar system, but it'll still be hundreds of years before it leaves the Oort cloud and the true full effects, gravitational effects, direct gravitational effects of our solar system. It'll take 75,000 years to pass the closest star. Yes, you heard that right. 75,000 years for an object moving 35,000 kilometers an hour to pass the closest star. So even if we were to find a way to accelerate to 100,000 kilometers an hour, it would still take 45,000 years to get to Alpha Centauri, our closest neighbor. So that's a long time. And that's assuming a constant 1 to 1.5 g continuous acceleration. That might get us up, to 100,000 kilometers an hour. Now, that means, imagine moving 100,000 kilometers an hour. Even if you hit a small rock, that's going to be like a bullet punching through. So the front of the ship will have to be heavily armored and angled to deflect a whole bunch of stuff. Plus, you have to have oxygen, energy, fuel. There's no way to refuel mid-flight in the middle of interstellar space. There's just not enough there. So you will be building these probably many kilometer long spaceships that'll have rotating cylinders for artificial gravity, and they're going to be huge, and they're going to have to be self-sufficient, and they're going to have to be very, very heavily armored and covered and protected against interstellar debris. So that's why I'm saying at least 500 years. We aren't even close to developing that level of technology to realistically have a chance at getting out of our solar system. Heck, we're at the cusp of technology to reliably get us to another planet. I think by the end of 2030, we'll have successfully landed and maybe brought someone home from the moon and Mars again, or the moon again and Mars, I should say. But we've barely begun to explore our solar system. in terms of setting people anywhere outside of Earth and the moon. And the moon is really close, comparatively speaking, compared to Mars or Venus or Mercury, or one of the moons of Saturn or Jupiter. So we have a lot of work to do before we can start building an interstellar spacecraft. I mean, we'd need to build a true interstellar spaceship would probably take 1 or 2 decades in and of itself. Then there's the problem of fueling it. It's going to be, you'd need a ship almost the same size as the spacecraft to provide fuel, because you have to take the fuel to accelerate and decelerate if you're going to try and colonize another place. So there's a lot of work that needs to go into that. I suspect more likely what we'll end up doing is creating an interstellar probe that would have just enough power to be able to send a signal that we could hear 4 years later, once it arrived at Alpha Centauri, that could map out the system and show us what's there, give us a good flyby of what's going on. But again, it'd take, even if we can accelerate it to half the speed of light, it'd still take 10 years to get there. And then 4.5 years for the data to get back to us. So we'd be looking at a 20-year type project. And that's assuming we could actually accelerate something fast enough to get there in that amount of time, which we can't currently do. So interstellar travel, not bloody likely. It's far, far away. We need to just perfect travel within our solar system first. That's Astronomy Answered Simply for today. Keep looking up, keep studying, keep asking questions, and like, subscribe, tell me what you want to learn more of. Thanks. Have a great day.